everyone. So good morning, good afternoon, or good evening, depending on where you're joining us from today. Welcome to session 8 of the Programmability webinar series with DevNet. Today's session is Play with Linux and Python on Networking Devices. If this is your first time joining us, no worries, we welcome you. And as soon as our presenter, Stuart, gets started today, I will go ahead and share a link in the chat window where you can go if you're interested in catching up on sessions 1 through 7. You can browse those topics and see which interest you and go ahead and access those recordings in the slide deck. Before we get started, just a few reminders. As Stuart is presenting today, please go ahead and use the Q&A panel to ask any questions. Please don't wait until the end for the Q&A session to go ahead and start submitting your questions. The more questions we have to start, the sooner we can get going on the questions, meaning the more questions that we will be able to answer during the live Q&A session at the end of today's webinar. So again, as we're going along, please submit your questions to the Q&A panel. If at any point through today's session you lose audio or maybe you can't see the slides that we're sharing, please use the chat panel to communicate with me directly, and I will do my best to get you back up and running smoothly as quickly as possible. We are recording, so a link to today's webinar will be sent out to everyone who registered for today's event. It will also be posted on the Programmability with Cisco DevNet blog, and it will also be posted on news and events on netacad.com. As always, at the end of today's session, you have to exit out of the WebEx environment for the survey to pop up. But please take just about a minute or two. It's a really quick survey, 6 questions. The answers are dropped down, so it shouldn't take long at all. But we do appreciate your feedback. We're always wanting to know how y'all enjoy the session or how we can improve sessions moving forward and what topics y'all are interested in the future. So as I mentioned, today is the 8th session. There are 9 sessions total in this webinar series. So again, here is a list of the webinars that we've run through so far. You can see we've covered many topics from security to programming to Python. So again, I will share the link in the chat window in just a second that you see here on the screen, and you can go to this blog and go through this entire series. And the next series will be in June, Automate Your Network with a Bot. With that being said, after that session is hosted, we will go ahead and open up the ability for you to sign up for a certificate of participation. Please understand that certificates of participation are not given for attending the individual sessions, but for participating in the series as a whole. So during that session in June, at the very end of the session, I will share a link where you can go and request a certificate. That option will stay open for you a month after the June session has been hosted. So at the beginning of July, just make sure that you have requested the certificate before then. We'll go ahead and close that out, and it'll take about a week or 2 for you to receive your certificate. It is kind of a long process, but we leave the opportunity open for students to be able to go back and watch the recordings and still earn that certificate for a month after the last live session. So if you've been joining us before, you know that we are going to also be doing a raffle at the end of this series. We'll be raffling off a total of 15 Amazon gift cards in the amount of $25 US at the end of the series. 10 of those gift cards will be raffled off to everyone who participated in all of the live sessions. I was chatting with a few of you before today, and I know a lot of you are on the call today, have been joining us for every session. So I know that we have a nice pool going of people to raffle off those gift cards to. The last remaining 5 Amazon gift cards in the amount of $25 US will be raffled off to everyone who has participated in the sessions by either attending the live sessions or viewing and downloading the recording. We understand that everyone has busy schedules with school and work and family, so I know that everyone can't attend the live sessions. So again, there are gift cards being raffled off to those who do a combination of the two as well. We want to be able to include everyone. So with that being said, let me go back to this. I'm going to go ahead and introduce to y'all and then turn the floor over to him. Our presenter today is Stuart Clark. Stuart's joining us from the UK today. He's a developer advocate for Cisco DevNet. He's worked for Cisco for over 7 years, designing, building, and troubleshooting Cisco Security Cloud Network with a strong focus on BGP, peering, and coffee, of course. His main focus is network automation, spending time on writing code for network automation at scale and moving networking towards a net DevOps methodology. So with that, Stewart. Thank you for joining, and thank you for putting together what I know is going to be a great presentation for our students and instructors. And I will pass you the ball, and the floor is all yours.
Thank you, Cara.
No problem. Welcome.
Thank you. Let's start sharing the deck. Let's have a look. Here we go. Okay. Thank you, everybody, for joining today. And that warm introduction from Cara there. We're going to talk today about to play with Linux and Python on network devices. As Cara mentioned, I've been with Cisco now for just over 7 years. I started my career in a service provider environment and worked my way up from a tier 1, tier 2, and tier 3 support roles before joining Cisco. And I worked on 2 of Cisco's largest global platforms, where I did a lot of network automation and orchestration to automate our workflows. And some of the things we're going to talk about today here, I'm going to show you, are things that I used in the production environment of those 2 Cisco environments. So it's really exciting stuff, and it's a great way to sort of build up your skills and increase your workflows and work more smoothly with Linux, Python, and network devices. So this will be our agenda today. We're going to talk about the architectures which are built on Linux. And some of you may or not know that most of Cisco's products is actually built on Linux architectures. We'll go through all of that and how it works throughout the sort of the different platforms and the pros, the cons, the benefits, and some of the examples there. Well, next we'll move down into Nexus examples with Linux and Bash access, and then we'll also have Python guest shell with shell examples with Cat9K and ISR 4K. This is all part of the demo here, so I've got about 10 or 15 slides for you, but I know you're all really interested in seeing how this actually works, in a more practical sense, and how you can apply this in your day-to-day. So in the demo there, we'll see pretty much everything that we covered in the first 3 items there in action, and how it all works and how it all glues together. Before we kick off, I always like to go over some of the technical terms. Acronyms, great thing, not just kind of the things you put on your WhatsApp messages or on your Twitter or Facebook, which they're the ones I kind of get stuck with these days, but the technical ones here are just the ones I'm going to cover here today. Some of them you may and may not know. Sometimes, you go through them and you speak about them quite a lot and you say them all the time, but, you don't necessarily know what the acronym sort of stands for. I'm very much guilty of that myself. We have to remember a lot of acronyms as engineers these days. One of the ones when I was typing this out was I had to remind myself what YUM meant, Yellow Dog Update Modifier. But these are some of the technical terms to go through. I like to kind of cover these off. Most of the time I will use the full name for them, but occasionally you will hear me say IOX, DNS, PIP, or CentOS or something like that. So when you're want to reviewing these, you can go back over the slides and just see some of the acronyms here. I've tried to spell them out as much as possible throughout the rest of the slides, but always important just to go over some of those in case you're unfamiliar with them or you need a refresh. So why Linux skills today? It's a really great question, and one I get asked quite heavily. I came from a Windows background, which is quite surprising. Most of the people in ISP world came from a Linux background. I was a little bit of a strange one going into ISP land, having a sort of a networking Windows background as opposed to a lot of my colleagues that came from Linux. On the right-hand side there, you'll see some of these companies and names which are kind of familiar to you, like GitHub and GitLab, Open Daylight, OpenStack, Docker, Kubernetes, K8, Linux Networking Stack, and Linux Network Operations, obviously, which Linux is a big user in. But the Linux open source community is another somewhat more surprising source of appeal to many companies nowadays. Gone are the days when companies perceive their success to be dependent on hoarding their code's functionality from the prying eyes of everyone else. Most companies acknowledge that because the technology world is advancing at a very breakneck pace right now, it's not realistic to maintain a system that doesn't have the benefits of hundreds of thousands of brilliant contributors from all over the world, which Linux certainly have. So tapping into that world requires employees who understand the Linux ecosystem, and this is why I'm kind of really employing people to sort of like take a look at Linux. Kind of one of the questions you get asked is, well, how much Linux do I need to know as an engineer or network engineer per se? That's a really interesting question, and the answer to that one kind of comes in a part where someone asked one of my colleagues who I work with the other day on my team who's French, how much of a percentage of the language would they need to understand or be able to speak, to be able to walk around France and converse and talk with people? And surprisingly, he said 15%. And I thought, well, that's interesting because 15% really wouldn't take a great deal to learn in any form or shape of language, but to communicate. And I thought, how does that translate into the Linux skills? And so looking into this a little more deeply, I would agree that knowing about 15% of Linux skills is probably the right amount of average. And if you base this over learning over a year, it pretty much, if you're learning at the average of 1% a day, it's pretty much really easy to get up to skills with Linux within a year and be really, really handy with it and kind of be that sort of Linux ninja skills that you really need today. As we've seen now in the network operations system world, and I mentioned before, that most of them are now variations of Linux, different vendors including Cisco offering varying degrees of access to the underlying Linux operating system, with the trend being able to give the user more access into the system internals. When we look at the physical network side, the ability to access the native Linux shell now enables us to install tools and applications once reserved just only for Linux servers. On the Linux server side, the simple host networking are quickly evaporated as more of the network logic goes into the Linux host. And really what that means is we've got all of these devices now which have been sat there just running kind of network operations and sort of like the routing protocols that we're all really used to. But now we can use them in like what's referred to as like fog computing, where we can actually use those devices just much more now than just as network devices themselves. Say, routers in particular is what I mean. I wanted to kind of bring this up just following on from what I mentioned about the 15% skills that you need and the sort of the kind of what skills you kind of need to get up and running. If when you're talking sort of different and various engineers across the spectrum in sort of networking and stuff, what I've listed out here, the sort of like the 7 kind of main things which I think are the most important things to use that Linux commands and its network prompt basics file systems. Editing, moving, copying, deleting files, changing file owners' permissions, and then managing processes from the command line. When we look into those a bit deeper, when I talk about Linux commands, a good example of that will be the cat command, which is short for concatenate. It's a great way to list contents of files on the terminal window, pretty much a lot faster than opening a file in an editor. And using the cat command, there's no chances you can actually alter the file as if you would, say, using Vim or Vi. Linux networking things, and one of my favorites that I've listed out here is MTR, or My Traceroute. I remember seeing this for the first time and seeing how really, really cool this was, and then quickly added this into the arsenal of kind of skills that I wanted to use. And there's all different flags you can use within the MTR. And if you're unfamiliar with this, it's a functionality of traditional ping and traceroute into a single tool, Similarly to traceroute, it'll show you every layer 3 hop between the source and destination, but also continuously pings each hop in the middle to validate if there's a specific hop or leading to access packet loss. This is really great if you're tracing from source or destination, or say somebody has an issue with accessing a particular URL or website and you're able to run MTR to see if there's any sort of bottleneck or taking place in the network or there's any problems. The MTR became one of my sort of favorite tools to go to when troubleshooting pretty much most issues. Another one which is really, really cool is TCP dump. Most network administrators are aware of the difficulty in capturing packets at any given point in the network. Commonly, we would use both a physical laptop to plug in and create a span or something on a local port switch, or ER span, to do packet capturing that you'll be familiar with something like Wireshark to capture the remote destination for analysis. But in either case, the external computer used to trigger the generation of the packets on file, used bandwidth and CPU, and was a waste on the switch. There's been a number of times where I've spanned a switch and caused the CPU on the device to absolutely rocket. There's also cases where you might not actually be physically able to get to the data center, and by using TCP dump on the devices themselves, you're able to sort of like do remote capture, save the file into the boot flash, and then analyze that by copying it from the boot flash down to your local machine. if you're used to doing any form of debug and stuff like that, you'll be kind of familiar with using TCP dump, especially if you've used ASA firewalls. When I talked about changing files and permissions and stuff, the command that we're using for that is chmod, and that's chmod, which sets up file permissions and flags on a file folder. The different flags define who can read, to write, or execute on that file, and that becomes quite important when you want someone to execute that file or you don't want someone to execute that file. Right down at the bottom there, I've got managing processes from the command line. We're familiar with the things like, show CPU and show CPU processes from the command line in the Cisco world. But then when we talk about using the Linux prompt for this, we have the top command, which is the sort of traditional way to see your system's usage, the processes that are taking up the most system resources. And the top will display a list of processes with the ones using the most CPU at the top. So this one becomes quite a good one if you're in the Linux shell within your router switch, to be actually see if any of the applications are taking up a little more CPU than they actually need to. Similar to that, the PS command lists the running processes, and that will actually give you all of the processes running within your file system. Granted, some of the examples there are, that I've covered there, that's not exclusively to the list, and you may want to add a few more to the skills that you need. As we say, your mileage may vary, and there might be a whole bunch of other things that you want to bolt onto your skills there as an engineer to sort of leverage those Linux skills and become that Linux ninja. We talk about the operating systems within Cisco and the different platforms that we have, and here I've just listed out the sort of 1, 2, 3, 4 sort of quick 5 and stuff, which we sort of like more find familiar and where we would actually see these within our network today. We have the sort of standard Cisco IOS, which pretty much all of us started on, which is found in borderless networks. For example, we've got the Cisco 39 series, the ISR2 router, which runs Cisco IOS. Cisco Nexus, which traditionally we kind of find in data centers. For example, the Cisco Nexus 9000 series switch, which runs Cisco NexIOS. If you come from a service provider background or service providers, you'll see that you'll find the Cisco XR platform generally in there. You don't tend to find too many XR platforms in enterprise. That tends to be pretty much XE or iOS. Then we've got the firewall sort of series and stuff, Cisco ASA for the family of services for security, which protects corporate networks, data centers, integrated application visibility and control. And these are sort of like the main platforms, but underneath all of this is the Linux architecture. And so if we just go into those architectures just that little much deeper in the sort of what I call the 3 sort of main platforms, XE, XR, and Nexus here. IOS XE retains the exact same look and feel as IOS. If you come from a sort of like an IOS background, transitioning into the XE background from the CLI was kind of very, very simple. Changing some of the commands due to the ability to use it in a multi-CPU, providing the enhanced features and improved functionality was always going to be a little bit of a change. There was features that you'd see in XE which you wouldn't find in iOS, like HA, for example. But the Cisco IOS software is modular, and it's built on a Linux kernel. The Linux kernel is designed to meet a greater requirement for security and high availability there. Additional system functions now run as additional separate processes within the host OS environment. The actual IOS XE software comes in 7 individual sub-packages of files, which are combined into a complete consolidated package file. So the XE is kind of the one that we're going to talk a little bit more about in the upcoming slides as well. I mentioned at the top of the hour I've done a lot more work with XE coming from the service provider background. Originally, it was designed for a 64-bit operation, and the IOS XE enhancements found in what we know as Nexus, for example, symmetric multiprocessing, separate memory space, and activity-only services are needed. However, while Nexus is built on a Linux kernel, IOS XR is built on the QNX. And QNX is similar to Unix, and it's now owned by BlackBerry, which was, I was quite surprised at when running through all of that information. Just looking at the Nexus, as I mentioned before when I was talking about XR, Nexus is built on a Linux kernel and now natively supports the Python language for creating scripts on Cisco Nexus switches, which we'll take a look at a little bit later. Additionally, it has high availability features and doesn't load all of its features in at once. So instead, if you're familiar with Nexus, you can specify which features you to use and activate, which is kind of cool, because if you come from, say, a programming language, you can look at something like Python or Go, for example. When you import the libraries in Python, even if you're not using them, nothing's said. No, nothing's done about that. But if you come from or have ever used Golang in a situation, if you import something from Golang and it's not being used, Golang will quickly tell you that that feature being enabled is pretty much a waste of time and it's not being used anywhere. So this is the nice thing about having the feature there, is you can just enable the things that you need or you don't need. And that pretty much frees up memory processing cycles for the features that you want and don't want. So huge advantages there for the features. I'll show you some of the features as we get down into the hands-on side or the demo side just in a bit of time. So this is where it takes a real twist, and this was kind of new to me up until about 2 years ago when I started looking into this. Traditionally, I'd run a lot of my automation and things off box. But here we're going to talk about an intro to running applications on Cisco devices or VMs or containers. So here I've pretty much listed out some of the greatest features and the reasons for actually doing this, like the fast feature delivery, the way this is independent from the OS and the release cycle, enabling some custom features basically for me only, for me to use on my own. Nobody else can get access to these. Tools providing easy integration into custom tool chains, security domains, integration of tools like Puppet and Chef and plugged in, Guest Shell, which we're going to talk heavily about in the upcoming slides, and then network applications. But these are pretty much the complements of the OS and the network element that we see today. Cisco IOS CLI applications are pre-packaged in containers using different formats, and I'm going to just jump around these 3 examples which I've listed out to you right now. And I'm going to start with the LXC, or the Linux container, just because if I explain this one first, it does make it a little bit easier when we talk about the KVM side. The required files for the LX package for the LX container is the disk image, and for the LX container, the disk image can be created using the standard Docker tools and Docker files to describe the base image. For example, this might be Ubuntu or CentOS or Alpine, etc., and the optional applications to be installed on top of those. The next part of that which comes in is the application descriptor, and this is written in a YAML file. If you've ever looked into network as code or IAC, for example, you'll be very familiar with YAML, or if you've done anything with, say, Ansible or templating, that you'll be familiar with YAML. And to start with, YAML was named not another markup language, but I think they've given it a different name moving on from that. But the YAML file provides that information for building the packages, such as the application description, say, authoring, versioning, things like that. The container type, the LXC, hardware resources, network interfaces, the disk image, and startup application. All of the provided files and information are used by the IOS client to build the LXC IOS container that can be then downloaded and stored on the XC device. Let me get rid of that. There we go. Then if we look at the KVM, for the KVM virtual machines, the workflow is very similar to the LXC that we talked about, with the disk image to be provided, and has the QCOW2 format instead. So that's QCOW and then number 2. The application descriptor for the VM is very similar to the LXC container as well, using an existing virtual machine running in the virtual environment, such as VirtualBox, and the related .vmdxk file can then be converted into the Q2 file format using tools like QEMU. If you want that spelled, that's QEMU-IMG, all in quotes there. Finally, then we've got the Docker containers. This makes the process of creating and maintaining the Linux image much more easier. You might be familiar for using Docker. I've used Docker in a few different sort of scenarios, but then coming to use them on box was a It's quite a refreshing change, and the ability to do that was actually really, really cool. While Docker containers are not natively supported in Cisco IXE platforms, Cisco provides a VM based on Alpine Linux, including Dockered, which allows network engineers or engineers to use Docker tools such as Docker Swarm or Kubernetes KH without having to rebuild containers. This approach then provides engineers, network engineers, basically with the flexibility to add any kernel module without relying on any modules provided by IOS CLI only. So Docker has its huge advantages there, and it's basically very quick and easy to deploy using the latest technologies. When we was talking about applications there and the kind of things that you might and might not want to install on the boxes here, I've put a couple of recommended things in here, and these are things that I actually started using when I was doing on-box applications with XE and IOX, just to sort of like help me with my day job and things. We've listed out performance and throughput testing, configuration management agents, packet collection and analysis, and Python applications. One common tool that I tended to use on the Catalyst 9K switch was the perf sonar, which acts as an endpoint to measure network statistics such as packet loss, latency, and jitter, similar to what we talked about when I was mentioning MTR earlier. But we can do this between any path on the private network, but also on the public network as well. And this goes into the perf sonar community to monitor network statistics to external geographies. I used to be a member of RIPE and LRingNog, which basically collects statistics as well, and you can buy third-party tools which will also collect geographical statistics as well. This proves really, really useful, for example, when you're looking at latency between, and I'm talking about global routing, for example, or something like that, where all different service providers are providing information into this space, like the sort of RIPE information or the RIPE looking glass. And you can see that by looking at the statistics through their portal, how the traffic is being manipulated or how the traffic has changed or any major outages. Generally, when you see service providers posting outages or, things like Facebook is down or something like that, or it's down to a routing issue, all of this information has been gathered from all of these statistics and things globally to see. Looking into those looking glasses and things, you kind of then know that it's not your network or maybe not your service provider. So a common one that kind of kept coming up for me was in the past is a submarine cable that connected was off the coast of Chennai and connected a submarine cable right into the coast of France. And often this cable would get dredged, and any traffic coming out of the sort of the India region through service providers like Airtel and Tata or something that was destined for, say, the United Kingdom, would then go across the land and come across the sea. And as we know, by going across the land, it increases the latency or the amount of hops or different types of network that it actually has to go through there. So using like RIPE stats or something like that, or using perf sonar from the community, not only from your local end, you're able to identify those things, but having them actually run on box is actually a really nice way to actually gather that information. And I like adding things into the community, and this is a great way to add that data into the community. And beyond the network performance of monitoring, administrators such as ourselves can run traffic generators tools on the switches to assist with connectivity and troubleshooting. If you're familiar with the ASA, you could use different tools on the ASA to actually do this from the command line, like packet trace or something. But that will only pretty much give you half the picture. And we mentioned about tracing through the network, but when you're on the box itself using tools like iPerf, you can see the traffic flows and you can point it to different parts of your network, and it can identify firewalls blocking specific TCP or UDP ports within a specific path. And it can be used for throughput testing prior to an application being deployed. And that kind of gives you a great example, like when an SRE team asks you to open a ACL or something like that within your network, and then something doesn't work. There might be an unknown port which the application is using. So before you actually make those changes across the network, you can use something like iPerf to check the ports that are open before making any changes. All these applications become really, really handy and help us do our job a lot more better. I did mention the recommended ones there on the left, but not such a great idea to actually store as applications on your Cisco devices, video games. Although I have highlighted there that Zork 1, the Great Underground of the Empire. You know, I'm kind of on the fence of that one. I think if you're going to install that, Zork 1 is a fantastic game. And if you're going to break that, we'll break it with Zork. Bitcoin and currency mining, yeah, please don't install any agents or anything like that onto your Cisco devices. It has been tried before, it has been done, and so not much great success. So they're the ones that I would say, you know, in my opinion, avoid putting on or downloading this application on your Cisco devices. When we again look at the sort of the containers and the virtual machines here, what I want to point out on this slide is that containers are almost like virtual machines, where containers have their own network interface and IP address. They can be bridge routed, just like XN, KVM, etc. However, containers have their own file system. For example, a Debian host can run a Fedora container and vice versa. For security, containers are isolated from each other, where two containers cannot harm or even see each other, which is a great advantage. And when I talked about before having this for me only, and I'm doing the quotes on quotes there, that's what I actually meant by that, the way they can't see each other, and that's exclusively to me if I want it to be. As far as resources and controls, containers are again isolated and have dedicated resources, so they have soft and hard quotas for RAM, CPU, and I/O, etc. However, what I wanted to point out was that apps in containers share the same kernel of the host OS, i.e. Linux guest only, for example. But the main takeaway from this slide is that containers are lightweight, fast to start, and allow for 10 to the power of density compared to VMs. So it just kind of shows the sort of the power of using containers over virtual machines when you're running them actually on your box. And then just quickly on this slide, the characteristics of the IOX container. IOX gives your applications container everything it needs to run your application at the edge. And we talked about fog computing right at the start there and running your applications at the edge. If you tell it how much resources to give your container, IOX pretty much here does all the rest for you. So you can deploy those containers and then you can set them to work straight away. One of the main things, or the applications that I talked about, again, just a couple of slides earlier, was Python. I'm a Python guy. I've been using Python for about 2 years, 3 years now. And by all means, I wouldn't consider myself as a Python expert. The way I would like to define myself is someone who can use Python to basically to make their job and life easier. I think that's kind of a little bit of a misconception that when network engineers started to do coding and started to do automation, that it kind of a little bit of a sort of like a panic came over, and all of a sudden you kind of had to be this, 100% shell guy, Python kind of person. And that really, really isn't the case. As I've started to go down the Python path, I have looked into actually, the underlying use cases of Python and using it outside of, network automation and things. But Python for me is the de facto automation language, and this is the language that we pretty much use across all of DevNet. If you've been in our learning labs or have been to any of the DevNet Express events, Python is the key language. I did mention Golang a little bit earlier as well, and this is a language I started to pick up recently as well. So another great language, which is kind of Pythonic, but Python being sort of my main one, and then I kind of back into Golang as my secondary language. Right at the start there, I mentioned that I was a Windows guy as well. And I think this is one of the reasons when I started learning Python that I really started fighting with it. And it didn't come easy. I expected to be able to pick this up. I considered myself a fairly smartish guy. I'm a CLI sort of Jedi. I've been using CLI for 10, 12 years now. But then switching and using to Python, I didn't pick it up as quickly as what I wanted to. And this is what I found when I was talking about the service provider area. And most of the guys that I work with being, sort of Linux guys before they became Cisco network engineers, and how quickly they adopted and were able to pick this up. There's a lot of the common traits from the Linux language which are used in Python. And if you've dabbled in Linux and you've dabbled in Python, you'll see, how those two languages are quite sort of similar. And the other thing that Python does is it helps us over operation shortcomings of the command line interface. And we can see a little bit of this coming up when we look at both onbox and onbox Python. Speaking of which, it leads us nicely into the next slide of using Python on Cisco. On the left there, we've got on-box Python, and on the right-hand side, we've got off-box Python. To start with, I used a heck of a lot of off-box Python. This was pretty much, executing Python against routers and switches and firewalls and those kind of things. And this is ideal for configuration management, automation. I used a lot of sort of automation using Python libraries like Napalm or NetMiko or PowerMiko. And then there's this sort of the IETF ones like RESTconf and NetConf, for example, as well for your transports, or even more modern ones such as gRPC, for example, for using scripts that we can externally use against the device. Later on to that, I'm going to switch on to the left-hand side where I talk about on-box Python, where the scripts are executed locally on the router or switches. And this was kind of new to me, and kind of cool in the same manner, is that I was able to take the Python skills that I got from executing and running automation against Cisco devices. I was actually able to then sort of leverage that and actually use them on the box. And on the left-hand side there, I've highlighted a couple of things, which is this is ideal for provisioning automation such as ZTP, so zero-touch provisioning, automating EEM responses, so that's embedded event manager responses, and application development, which we talked about in the slides, and then the Internet of Things, IoT. I have only listed the two things here, the on-box Python and the off-box Python. However, it is worth mentioning there are actually three operational approaches to programmability to integrate with network elements. Although we're looking at the sort of like the two main ones here, and the two main ones are here, we've got the other way as well, which is via a controller such as Cisco DNA Center, where you can actually have the device reach back out to the DNA Center or the controller, and the controller actually make the scripts. So what happens here is the device, for example, receives a number of routes or loses a number of routes, and it goes back up to that controller and says and alerts it to say that's happened. And then the actual DNA Center, the controller, will then execute the changes back on the device itself. So all of the logging and things is actually done on the device. A similar way to the way the ZTP works, it pretty much calls out and says, these are the changes that have happened. We need remediation here. Something needs to happen. We can do this via the configuration management tool, which is very, very similar to DevOps. Or again, we mentioned that we could do it directly on the device, which is, the on-box Python that we spoke about. Each comes with various benefits and trade-offs. Again, I'm always putting the caveat in there that your mileage may vary. You might not have DNA Center, you might not have controllers. You might not have the ability to actually run the on-box, or you might not have the ability to run the off-box. Everybody's environment is always different, so it's always great to have these kind of three different options. But the Cisco IOS CLI network OS has been designed to enable all three of the integrations that we spoke about there. So the Python libraries we can use as the collection of the different modules which allow that access to be performed without having to create new code. And we spoke a little bit about the Python libraries and modules that contain certain definitions and statements that are identified within Python. So now it comes up to the fun part, and this is the thing that I always like doing, the live demos, and there's nothing better than doing a live demo on a Wednesday. So let's jump into our command line. So you'll see I've brought up my shell command. I'm using a Mac, and what I've done is I've just used the Mac terminal here just to SSH into a dev box, and this is all powered in the DevNet sandbox. And what I'm using here is actually the multi-IOS viral instance, and I can show you the nodes that I'm actually running here. I've built a full topology within viral, and then I've used something called viral utils to actually bring this up. If you're not familiar with viral utils, it's one of those great things that I recommend you check out if you're using viral. It's good if you're familiar with something like the tool called Vagrant. The way that you can bring devices up with viral or the viral utils is very, very useful. It has that sort of viral up syntax or viral destroy, and you can use a lot of other different commands which you'll see me run through here to actually hop in and out of the network devices and actually see the topology here. Viral utils will save you a lot of time if you're using viral and want to build topologies for just your own sort of like personal use, or if you're using this in a CI/CD sort of continuous integration continuous deployment environment where you want to test your changes before you're pushing them out to the network, or your production network, should I say. So what I'm going to do now is I'm going to jump into this device here, which is distribution 1 here on the left-hand side. And as you'll see, this is a virtualized Nexus 9000. A couple of ways to get into this. You'll see that it says protocol telnet down there on the middle screen. If there's any security people on the call, please don't panic. This is in a sandbox environment, so I'm pretty much safe using telnet for now. But the way I'm going to actually jump into this is I'm actually going to use the console command. And this is very, very similar to how if we had a terminal server or something like that attached into the console or as locally consoled into there. The nice thing about the console device is you can actually see the device coming up or any problems with the device booting. So it's always good, you know, if you're jumping around in here and you have a device which comes as unreachable, you still have access to it as opposed to going in on the management IP via SSH or Telnet. So let me jump into this for a second here. It should just connect right up. He says. There we go. So a quick username and password, and then you'll see basically I'm straight into the switch as we would be. You can see here all the information that we're running. That's the 9000D switch. The Open Nexus provides support for standard package management, as we talked about, and it supports 2 possibilities for hosting environments of packages. We have the bash shell, and then we have the guest shell. The bash shell, this is the native Open Nexus Linux environment and is disabled by default. A little bit before we talked about the features, but to enable this, we actually have to set this in as a feature. So if I just do show run include bash, you'll see there that feature bash has to be enabled. Guest shell, this is the secure Linux container environment running CentOS 07. And the focus of this section is to be manage packages in the bash shell or the native Linux environment where Nexus runs. The guest shell is actually enabled by default, which we'll see as a slightly different turn on it to how we see in the when I do the next demo where we jump into the XE shell where it's not enabled by default. So the idea is on here is what we're going to do is we're going to look at some of the Linux commands that we talked about and how these can be used to your advantage when using guest shell. And I'll try to cover both bash and guest shell in both of those commands and just show you a little bit of the difference in here. So the first one I'm going to do is actually run the bash command instead. So simply just to get into the bash command on the device, you can just simply just hit run bash. And that puts us straight into the bash command. If you're familiar with the Linux shell, you'll see that sort of $sign there, and it says bash 4.3 there. And now here, this feels and looks just like a Linux box. So I can use my Linux commands like ls for list, you don't see anything, lsxa, oops, got a space in there, which gives us a little bit more of a granular look on there. We talked about the processes and operations in the slides of the commands you want to know, and we can look at the top command here. This pretty much prints this out and tells us all the top processes which are run. This is interactive, and once you've got this running, the way to get out of this is Control D. Oops, should be Control D. Oops, open this as a command there. There we go. Let's jump out of that one. It's refusing to quit for a second. There you go. And now we're back onto the bash prompt there. The other command I wanted to show you on there, if you're familiar with this one as well, if you wanted to see the interfaces that we've got running on the devices themselves, ifconfig as well works really nicely, and that pretty much pushes out all the interfaces that we have on the physical device. So this is kind of something like show interfaces or show interfaces brief, which will bring up that same thing. You can go in there a little bit more granular as well and look at each individual configuration. So I'm just going to look at E3, for example. And then we can look at the VLANs as well. You've noticed on that switch, let me just scoot up there. I've got a number of SVIs running on this device. Let me just scoot up there just a second. Where are they? Further near the top. Keep going. Oh, they've gone off the shell. Let's just have a look at one of those individually. So we have VLAN 100. Have I got VLAN 100? No, I don't. Let me have a look for VLAN 100. VLAN 103. Let me just do that again. See if I can catch it, see which VLANs we've got running on the switch. Oh, that's interesting. I don't think there's a VLAN running now. One thing to note about if you're running the VLAN command, you actually do have to use the capital V there. That's quite important. If you run the lowercase v, you pretty much you won't see anything. We can look at the routing information as well there, just by the simple root command, and you'll see that I've just got two routes which are installed there. The other thing that we can do is we can create files as well, pretty much the same way as that we can from a command line. I'm just going to use the touch feature here, which will create that, and I'm just going to create a text file called moo.txt. If I use then the ls command, I can see that command. And if I wanted to edit that command and put something in it, I can use vi. Vi is very similar to vim and acts as an editor. And then I just hit this one. I press escape and I, and then what I'm going to put is hello world, and then escape, and then right quit to save that off. Now, if I cat this, when we mentioned concatenate earlier to look at the file there, cat will actually show us what's in that file itself. So here we can create files and we can look into those files. And I'm using a text file just as an example there. We can even make directories as well. There's often a case where you want to have certain directories with certain files in it for certain applications or on-box scripting, and you can make a specific folder for those to be in there, and we do that with the make directory. The way to do that, just make directories, you see on the left-hand side there, and I'm going to call that directory moo. One second, I've done a bit of a typo. That should be make mkdri, apologies, there you go. And then we list it out there, and we can actually see there that I've got this directory called moo, and then we can change directory into it. And then we can see where we are on the command line with the pwd. This shows us that we're in the boot flash, home, Cisco, and now we're in this directory called moo. Simply to go back up to the root directory, we just type cd, and that takes us back up to the top level directory. And if I type pwd again, you'll see there that we're in pretty much the home directory of Cisco. Now, say for example, we wanted to move that file, we created that text file, or we created a Python file, that moo.txt, and we wanted to move it into that folder. We can do exactly the same as what we did. And this is something we talked about right at the top of the arrow again with the commands and moving and changing file structures. We can just copy moo.txt, put the tilde in there. Oops, let's see. Am I done? Oh, where's that gone to? File seems to have disappeared. Let me just exit out the bash shell 1 second. Jump right back into the bash shell. Run bash, ls, there we go. pwd, home Cisco, that's strange. So moo.txt to the /. Oops. There we go. And now what should happen is, if we go to cd moo, change into the directory, list those out, that should have appeared there. That's interesting. Always the fun of live demos. Let me try that again. So let's see, copy that, copy, oh I know, moo.txt, then tilde to moo, oops, so I can put space in there, moo, copy that into there, that's nothing. No, for some reason I can't copy that, apologies. Okay. Moving forward on there, we can look at the different things in here. So far, I'm just using this in basic admin mode, but in the Linux world, we have this concept of sudo or super user, which is just sudo, to type here to get into that mode. But the other thing we can look at is the pip freeze, and this will show us all of the modules that are imported here using the pip command, or what have been imported from the pip command. The nice thing about pip is if you're not familiar with it, is that pip is used to install different Python libraries in here. And here you'll see some of the default Python libraries which are pre-installed on the device already. Similarly, pycurl or pathlib or smart URL grabber. And then the yum metadata, we talked about the yellow at the top of the arrow there for basically yum installing packages as well. So that's installed as well here. A great question which comes along now and again is that from within Bash you have the capacity to execute Nexus commands. So if you're on the Linux shell and you're doing something, you know, you could go back and just exit back out of here like you saw me do, and then jump into back into the CLI. But if you're kind of savvy with your commands here, you can actually use the Linux shell here to actually execute, you know, the sort of the basic sort of CLI commands which we're used to. And we do this with the virtual shell utility, which is a VSH for short, and this enables us to use the Bash utility sed, grep, and awk, again, to pass output to produce proper formatting. So to actually see this in action, we just type VSH hyphen then C for command, and now I'm just going to type of a command which will be familiar if you've used a lot of Cisco device. Information is show IP in brief, and then close it with quote marks. And that would show us if we had any interfaces actually up or in the up status, those commands. And we can use this again to actually just granulate and go back into a bit more information here. So I could go in and do something like show int eth 1 brief. Command could not execute. So it's having trouble looking for that interface there. Let me just do an if command and just see. It doesn't look if like some of the interfaces have come up on the switch itself. I'll tell you what I'm going to do. I'm just going to exit just out of there for a second, show IP in brief. Just jump back into there. It looks like some of the interfaces haven't come up on the device. Show run. Oops, show run interface. Yeah, it looks like some of the interfaces just haven't actually come up on this device. They've actually stayed in the down state, which is a bit strange. What I'm going to do is I'm just going to jump out of this one just for a second. And I'm going to just jump into this 2 instead and just take a look here. See if this one has, maybe the switch had reloaded and it had lost its configuration. So show IP in brief. Let me just take a look here. No, pretty much the same on there. Let me jump into the shell. So if you run bash and just jump into the bash shell of this device one more time. So in here we can actually make changes to the interfaces, and the way that we would do that is you can run commands from there. Again, use the root or the sort of like the root command or super user command, which is sudo. This one's just a little bit laggy. So it's if you use sudo and then do if config, what we could do then is capital E eth 1.5, and then you would type the down command. And what this would do is, in theory, if this interface was actually up, it would actually shut this command. This would actually administratively shut this down. Now, I'm going to go back and use the VS command there, which we did before, just to quantify that I actually did shut that down. So remember we did VSH, then C. Then open the quotes, and I want to do show interface eth 1-5 brief, close the question mark. It's not passing that error, which is really, really strange. If I jump out of there just to confirm that. So if I look at show run Ethernet 1-5, let's have a look. 1.5. Oops, a slash, isn't it? Oh dear. Let's have a look there. There you go. I wanted to validate that from the bash command, but for some reason it's not actually showing the bash. It's not actually showing it through the bash shell, which is really strange. So we see we've actually shut that interface down. Now, for example, if I wanted to, I could unadmin shut that. We use the command like that, interface down, and then to change that to actually bring the interface into the up state, we just use the up command instead. it'd be nice to actually validate this from the guest shell, but for some reason I can't understand why that doesn't just work for a second. Let's see, show interface. If I wonder if I need to use the slash notation. There you go. So you had to use the slash notation. That might come clear in the next example why using the hyphen and the slash example is just different. But you can then use those the VSH command then to actually manipulate and control your configuration. I'm going to jump back out of there just for a second. You'll notice that when we started this, I went straight in at the bash command, but the other one that we have here available to us is actually the guest shell. To get into guest shell, pretty simple. Guest shell run. Oops. Or is it run guest shell? It should just take a second to start, and then we're in the guest shell command. A lot of the commands that you saw me run in the bash there, very, very similar. ls -la gives you the same output as well. A lot of the commands that you can run in the bash prompt, you can actually again run in there. The only thing that I have found that is actually different is that if we wanted to look at configuration where we use the VSH, we can actually use the do host command instead. That should all be one word. Do host. And then you can just use show, there you go, show IP int brief. I am abbreviating my commands.
Hi, Stuart. We have just a few minutes left.
Okay, no problem. Thank you. Okay, so with a few minutes left, I just want to jump quickly then into the other side of the demonstration that we had. You'll see that I had
Stuart, are you there?
sorry, my screen's just locked up. Oh, there you go. So I just wanted to show you this just before we closed out. I want to jump into the XE device that I've got here, which is Core 1. XE device, very, very similar, but in a different manner where guest shell is enabled on Nexus by default. Guest shell, you actually have to enable. Yep, there you go. 1 second. Show run include IOX. You have to enable IOX, and then the other thing you have to enable is the application itself. So if I just show app there, you can see that I've enabled that as well, along with a gateway and a couple of other features. But to get into guest shell, it's same as what we did before by just doing run guest shell. Oops, oh sorry, guest shell run. Or is it guest shell bash? Let's do guest shell bash. I've got that enabled, so all of a sudden it looks like this box has broken. It should just be run. There you go. So then it just drops us straight into the bash prompt here. I talked a little bit before about having unboxed devices as well, and you'll see here that I've got a Python script on the box, and we can use the cat command for this. And here you'll see that I've just got a simple Python script on here, which is embedded into the event manager and will execute once we've used a Python script against the box. But it shows the power of being able to have the Python scripts actually running within the box and running there with an event manager. Carl, am I okay to demonstrate that? Do we have just a second?
Can you stay a little over? We still have questions that we have lined up from the students also.
Yeah, absolutely. I can stay as long as you need.
Okay, I was going to say, I know the students are usually typically okay staying about 15 minutes. In fact, we've gotten a lot of comments that they'd rather see more content in the webinar go, but I didn't know if you had anything lined up after this.
Some more content? Which content would they like to see?
Oh, no, I was just saying, just in general, the feedback after these are usually, they don't mind staying a little longer if there's more content in the webinars, but I didn't know if you had anything lined up after this. But everyone, I know we have a pretty big group on, so if you need to drop, please feel free to do so. I will be sending out the recording if you'd like to go back and listen to the Q&A portion at a later time.
Cool. Okay, let me close out on this final section then, because this is super cool. So you'll see that I created a Python file on there, and I did it in the same manner that I created the text file. So basically, I just did a touch file to be able to do that. You do have the ability to run actually Python natively, like you have with the Python REPL, and you can see here that just by doing the Python-V, you can see the Python version here is 2.7, and you can go into that in the same way as you would opening a Python here, and it works very much like the REPL does in Python. So we can just do A equals hello world. Oops. A equals hello world, and then we can do print A. And this works exactly like the Python REPL would. So you can create and test your sort of Python through in here with the different Python things. If the library isn't installed, you can always pip install this as well. Exiting out of there is just like you would normal Python. You can just hit Control and D just to jump straight out of there. I mentioned then that we've got this Python script on here, and you can see here that I'm using the CLI configure rep command, and what this will do is it will go into my BGP instance that I'm running on this, and it will actually shut it down, or it'll actually issue those commands to the command line as if it was a human doing this. There's a good reason for doing this. When I was talking about working in a service provider environment, we had a lot of BGP sessions, and if you're familiar with how peering works at internet exchanges or something like that, where you have one interface with multiple BGP sessions running over it, this becomes really handy, because monitoring 2,000 BGP sessions off a router and then administering all of those can become a very much a full-time job. So what I wanted to do was actually have this unbox Python script doing all of the work for me, so I didn't have to log into the device and then keep issuing a BGP shut or something like that. So what I'm going to do is I'm just going to jump back out of the guest shell here, and the way to do that is just simply exit guest shell, and it takes me back to my prompt. And then if I just do a show run here, and then I'll scoot down a little bit further, and I'll show the EEM script, which is running on the box. A little bit further. There we go. And then I've got this event Apple management, and I mentioned that at the start, the EEM or the event management applet here. And this is BGP Jack. And what it's going to do is it's going to monitor a syslog pattern called track6state. And that's monitoring a tracking, which is just simply sending a ping to an upstream device or one of the other CSR routers I have in my topology. Then it's going to go here and basically hit the enable command, and then it's going to jump straight into here. And you'll see here what I'm specifying is that when we did that PWD and you saw the home, it goes into the home guest shell, and then it says the Python, then it says Python, Python.py hyphen syslog, and then so what will happen here is the syslog will actually trigger that event. So the aim of the game here is actually send an off-box Python script to interact with an on-box Python script. So here we're sort of leveraging the two powers of Python to actually use our on-box and off-box. So if I just did a quick BGP summary, and what you'll see is I've just got this one session up here, and this is peering to just another CSR within the topology. I'm just going to scoot this over so you can see my other screen here. I'm just going to bring this out. And what I've got on this right-hand side here is just a simple Python script, and the Python script will go in and it will create packet loss to the tracking which I have on the left-hand screen to the device. And what I can do is I can first of all just get the BGP information. So I'm running this Python script on the right-hand side, and it's telling me that on this device, and let me just do show IP in brief, This is actually 58, so let me just change that. And it'll see exactly what we see on the screen. You'll see on the left-hand side, because I'm on the console, it's logging everything. So it's basically logging everything that I do when I log into here to actually hit that command. But you'll see the same thing from the Python script. So I don't have to log into the devices anymore. I can use Python to log into my Cisco device to get the status there. And I can see the same information that we saw from the show BGP summary here, but I'm using a REST-conf as my transport, and then I'm using YDK to actually send the commands directly to the box itself, or I'm using the Cisco IOS CLI YANG data to actually get that information back. But now I want to actually create that issue from here, so I'm gonna just change that around a little bit and actually create what would be almost packet loss. And this is just running the same sort of script under add drop. And what this will do is it'll trigger a Python script to one of the other upstream devices to actually simulate packet loss. I have set the tracking and EEM very aggressively. If you was doing this in a production environment, it's always best to have your on-box Python scripts probably wait about 10 or 15 minutes, especially if you're dealing with BGP, because as we know, BGP can be a little bit flappy, or if you're monitoring latency, for example, sometimes the latency can disappear quite quickly. It might just be CPU of an upstream device is having a bit of problem, or there's been some path renegotiation or something to trigger that. So you don't really want to be taking your BGP sessions up and down really quickly. So a 15-minute sleep timer is ideal to build into the tracking or EEM event manager, but your environments may vary just a tad there. So what this will do is this script will go into the device and it will simulate the packet loss. And what I need to actually, that's wrong. I need to do this on 59. Apologies. I need to do this on this device. I need to do it on the other device. Select interface here. And now I'm just going to put this in as interface 4 is what I want to apply this to, and it says task completed. And then hopefully what we should see on this left-hand side is the actual tracking and the device actually go down. Although, however, I think I might have broken that now. I think my sandbox device is just reloaded. Yeah, you can see that my device is just reloaded here, and we're actually going into the golden image there. So let me just execute out of here. What should actually happen is that we should go into the Core 2 device here, and it should apply a ACL onto the interface. I can see that this device is having a little bit of problems. Okay, oh, there you go. So what you would actually see is on this device, it should apply this access group in, and I'm using Python now off box to actually apply a configuration change. What that would have done was it would have executed the EEM script and then ran that unbox Python script had the device not reloaded to actually shut down the BGP session. If we do show BGP on this side, we will actually see the actual session or the state on this side. States remained up. Let me just check back in there to see how that's gone. Let's have a look. I think this device is actually trying to reload itself. Let's have a look. Yeah, it looks like that device is reloading itself. Okay. Okay. Let's have a look. So in summary,
5 minutes before we need to close.
Yeah. No problem. So in summary then, we looked at the architectures of the Cisco platforms, which are all built on Linux, and then we looked at Nexus examples with Linux, with bash access. We looked at the Python guest shell examples within a Cat9K, ISR 4K, but using IOS CLI, and we did all that within the demo time, but apologies for the sandbox crashing right there at the sort of the crescendo sort of moment where the actual EEM and Python script would actually run and see that demo. If you want to learn more about this, the Cisco Networking Learning Academy has a huge bunch of resources there for program PCAP Essentials with Python and some Linux courses as well. DevNet has the Coding Fundamentals course, which is fantastic, and then the Introduction to Guest Shell on iOS XE, where you can run through all those examples that I've shown you today using Guest Shell on iOS XE. All the sandboxes, I've listed those out in there, and the slides there, the Catalyst 9000 and the iOS XE programmability box for you to get your hands on. You just need a DevNet account there. If you've got any more questions, my information is all there on the front. There's some follow-up questions if you wanted to talk more about some of the demo or get the code that I've used today. I'd love to talk to you a little bit more about the code if we had a little more time. Thank you, Cara. That pretty much concludes the session.
Thank you so much, Stuart. I know that the students really enjoyed the demo, so thank you for going through that with them. They love demos.
The demo gods weren't with us.
So I'm going to jump right into the question, Stuart, if you're okay with that.
Yeah, absolutely.
The first question was Python. Is there a Python library to create Linux scripts?
Python library to create Linux scripts. Oh, sort of like with Bash. It depends on the platform. If you take XR, for example, when you go into the Bash prompt there, you use TCL for creating Bash scripts in there. But I'm not aware of a Python library that would create Bash scripts per se. Bash is on its own programmable language. The question, I guess, can you create Bash scripts like you could from a Bash prompt and then have them within a file to action stuff on the router or switch from within the Bash shell? Yes, you could, but there's no Python script to do that.
Thank you, Stuart. And can Python also be used to configure ESA and WSA?
Yes, it can. You have to check the train version. The ASA has an API, like most of Cisco's products has an API, and you can use that API much similar to what you saw me using today, off box, and you would connect to that API. There's a number of different ways and resources you can connect to that API, via SSH, netconf, sconf, etc., to be able to run Python scripts against your ASA. Yeah, totally possible.
Thank you, Stuart. And the next question was, what version of Python on box does Cisco equipment use?
You saw me there using 2.7, and it greatly depends there on the version of Guest Shell as well. Depending on the resources of the devices, within the virtualized environment, this is using Guest Shell Lite, so it tends to use, by default, Python 2.7. However, if you're using Guest Shell 2, I believe, that will use Python 3.
Thanks, Stuart. And are there alternatives for deploying scripts rather than to a live switch router devices, like using GNS3 or with Cisco Packet Tracer?
So I was using Viral, but yes, you can use GNS3 for doing your simulations. I've seen a lot of people do this. I'm not sure about Packet Tracer, but certainly within GNS3 and Viral, you can, the infrastructure that I was using today was all Viral. So very similar to GNS3 in the way that you would connect to it. You could have a dev box running within your GNS3 environment, or like I had a dev box running within your Viral environment just to connect to the routers. Yep, totally possible.
And then what is the hotkey to leave the switch console?
On my Mac, if I'm on the console and I've telnetted in, I would use Control, and then it's the button right next to the return, which has the curly braces or closed square brackets. And then it will take you to a prompt that says telnet, and then you just quit straight from there. Yeah.
And Stuart, is it possible to install new libraries to Python on box of Cisco equipment?
It totally is. Yep, you can use the pip command to do that, but you have to ensure that your device obviously has a connection out to the internet, and Guest Shell by default will use the management VRF for connection outbound to the internet to bring those to when you do a pip install. Yeah.
Thanks, Stuart. And then during the demo, a student asked, can this be implemented on the DevNet sandbox? What would you recommend?
It totally can. This was exactly the DevNet sandbox. I'm using the multi-IOS sandbox viral instance. And if there's a link in the slides here, which will take you to the code itself, and then using viral utils, it will spin up the topology, and then you can have a go yourself with all of this I've showed you today, including the Python code, which uses object-oriented programming, and also a feature called click, which is similar to the Python library argsparse.
Thank you so much, Stuart. Again, I really appreciate you joining to give such a great presentation and demo today. I know the feedback has been really positive in the chat window. So thank you so much for volunteering your time to come and help our students and instructors. And like always, I have to say thank you to Joseph and Wadi, who are also panelists on the call, for answering so many questions in the Q&A panel.
Thanks, guys.
So thanks, guys. I'm going to take the ball back real quick, and just a quick reminder that, again, the next session, which will be the last session of the DevNet series, is going to be in June. It'll come up really quick. I believe it's June 8th, but I did not want to say a date in case that was wrong. I am going to put the link again back into the chat panel where you can go and register for that session, and the date will be on that blog. We talked a lot about Python today, so if you're interested, we've set up a free self-paced course for those interested in going and enrolling into the Python Essentials course. It is an intermediate course. No prior knowledge of programming is required. And again, it is a free online self-paced course that is 70 hours long to complete. So I will share both links in the chat window. And again, thank you to all of our students and instructors who joined us today. I love how everyone stayed on for the last part of the demo. So thank you, everyone, and we will hopefully talk to you in June. Thanks, guys.
Thank you all.